Welcome to solverfy.
This is the answer to chapter 15, problem number 50 from the Smith Organic Chemistry textbook. And so this problem gives us a series of unknowns and a series of reactions, and then gives us two final products. It gives us some molecular formulas, and it asks us to identify these four unknowns. And so the first thing that I did was just draw out the sequence that they've given us, because I think that that makes it a little easier to handle. And then I wrote out the other information that we're given, the molecular formulas. I like to start problems like this way by rewriting everything that I've been given, just so that I have it in front of me to look at. And so the place to start here, I think, is to start at the end and work backwards. So we're given these two final products, and we're told that they are synthesized from unknown D by ozanalysis. And so hopefully you remember the way that ozanalysis works. It's going to cleave double or triple bonds. And in this case, it's going to be double bond, and it's going to cleave that double bond into two carbonyls. And so these are the two carbonyls that were given as final products. And so basically, down here, I rewrote them so that it's a little easier to see how they fit back together. But yeah, you just fit them back together, carbonyl to carbonyl, and then that gets you to D. And then perhaps go back to the beginning of the reaction and think, so we have an alkane, and we should know that it's an alkane because we can quickly calculate the hydrogen deficiency index for this formula. So remember, it's going to be 2 times the number of carbons plus 2 minus the number of hydrogens, all of that over 2. And so for A here, it's going to be 20 minus 18 over 2, or 2 over 2, or 1. And obviously, we have a ring present, and so that ring is going to account for that 1. So we know that A is an alkane, a cyclic alkane. Probably a monosubstituted cyclohexane. And we should know that free radical bromination is going to add a bromine to that alkane. But we don't know exactly what the alkane is. But if we think about, so B and C are going to be an alkyl halide. They're each going to be an alkyl halide of some kind. And then if we think, well, potassium terbutoxide is going to do an elimination reaction when an alkyl halide is treated with it. And the product of an elimination reaction is going to be an alkene. And so D is going to be an alkene, and we already know which alkene it's going to be. So we can then work backwards from D to get to B and C, where we just have the bromine on either carbon of that alkene. And so either of these could really be B or C. There's no information in the problem to tell which is which. And then from there, obviously, we now have the basic structure of our starting alkane A. And so we can just work backwards, get rid of the bromine, replace it with a hydrogen, and that's how we get A, our starting alkane. And so, again, I think the way to solve this is to write everything that you're given out, and then work backwards from this known product that we've been given, to think about, what these products would start as from the ozanalysis reaction. And so that is the answer to chapter 15, problem number 50.